All right, so this whole unit is about ratios and proportions. And one of the most common places that you're going to use this is if you're following a recipe. So we have this recipe given to us, and it tells us that it yields 3 dozen cookies. And we want to know how much of each ingredient we need to get 18 dozen cookies. So we're making a whole lot of cookies. So here's our ingredient list. If we're trying to go from 3 dozen to 18 dozen, we are trying to multiply this recipe by 6. So every ingredient here has to be multiplied by 6. So we need 6 cups of flour. We need 3 teaspoons of baking soda, 3 teaspoons of salt, 3 cups of butter, 2 cups of brown sugar, 6 eggs, 3 teaspoons of vanilla, and 6 cups of chocolate chips. So, I think a lot of us have experience with, looking at a recipe and thinking about if we need to double or triple the recipe. What if the recipe actually calls for more than we want to make? So in this example, we have this meatball recipe, and it makes a certain amount. Let's see, it tells us it makes 12 servings, but we only want to make 6 servings. So think about what you would do, pause the video, and then come back here and check your answer. Okay, so if I'm trying to go from 12 servings to 6 servings, I'm trying to halve the recipe, or take half of each ingredient. So I need 1 pound of ground beef. I need a 1/4 cup of breadcrumbs. I need 1/8 a cup of the Parmesan cheese, 1/8 a cup of milk. I need a 1/2 a cup of the beef broth. I need 1/2 an egg. That might be tricky. I need 1/8 a cup of chopped broccoli. I need, 1/2 a tablespoon of minced garlic. A 1/4 tablespoon of kosher salt, a 1/4 tablespoon of pepper, and a 1/2 teaspoon of oregano, and 1/8 a teaspoon of crushed red pepper flakes. So our idea here is that we have all of these ingredients, and we're either scaling them up or scaling them down to make more or less than the recipe calls for. So similar to that idea, let's say that we know the perimeter of a triangle is 240 centimeters. Now we know the ratio of the sides are 8 to 7 to 5. So let's just say I'm picturing my triangle to look like this, but the length of each side isn't 8, 7, and 5, or else it wouldn't add up to 240. So I need to scale each of these up by the same number so that I have that same ratio, 8 to 7 to 5. And so I'm going to scale each one by some amount x, right? The same scale factor to get 240. And so I'm going to go ahead and add that up, and I get 20x. Let's see, did I add that right? I did. Okay, so we get 20x. And now we get 24/20ths, which is, let's see, I could divide by 4, 6/5. So my scale factor is 6/5. So now I want to use that to find the measure of the longest side. So I figured out what my scale factor is. I know this has to be the longest side, so I'm going to multiply 8 times 6/5 to get 48/5 centimeters as my longest side, because I have centimeters as my unit of length here. All right, go ahead and pause the video and give this example a try. Similar idea, you know the ratio of the angles this time. All right, so hopefully you gave this one a try. The correct answer, remember, classifying the triangle means we're saying what type of triangle. So by the angles, we actually find out that we have a right triangle and all three sides are different, so that means it is scaling. So we have a right scaling triangle. If you're still having trouble, if you got something different, check in with your teammate and see if you can figure out what went wrong. All right, now we're going to do some algebra review, which is going to help us to move forward when we are setting up triangle proportions here. So I'm just going to refresh us a little bit as to what cross multiplying looks like. So when we have a setup like this is actually a setup that we're going to see quite frequently with a proportion, one proportion set up to another. So when I see this, I'm going to go ahead and cross multiply. So 6 times root 3, and then 2 times x. And so we can only do this if we have a fraction equal to a fraction. That's the only time that you can use the strategy of cross multiplication. So here's I did my cross multiplying. I'm almost done, except I need to divide both sides by 2. Now here's another part of the algebra here. I'm not going to divide both of these by 2 because they're already being multiplied by each other. So I'm just going to simplify. 6 divided by 2 is 3. So I get that x must be 3 root 3. All right, go ahead and try example 1. Pause the video. All right, so for example 1, you should get x equals 28. Go ahead and check your answer there. Okay, so for example 4, we're going to use the same strategy. Now you might be saying, well, wait, we have a fraction on the left, but do we have a fraction on the right? Anytime you have an integer or a whole number, you can just put it over 1 to make your fraction. So we do have a fraction equal to a fraction, and now we can cross multiply. The key when you have something like this example that we have, is to make sure that you're distributing. So when I say we're going to multiply x plus 7 times 1, we're going to multiply all of x plus 7 by 1. And when I say we're going to multiply 2 times 11 minus 2x, we have to multiply 2 times the entire 11 minus 2x. So whenever we cross multiply, we have to make sure that we're setting it up with parentheses like this so that we can distribute. Okay, so I'm going to distribute my 1. I get x plus 7 equals. And I'm going to distribute this 2, so I get 22 minus 4x. And now I can finish solving. So I'm going to add 4x to both sides. I get 5x plus 7 equals 22. So I get 5x is equal to 15. So x is equal to 3. Try example 3 and then unpause when you're ready to check your answer. All right, so the correct answer for this one is x equals 10. If you got something different than x equals 10, double check, did you use distribution here? Okay, did you correctly distribute when you cross multiplied? All right, one more example here. What happens if we have an x times an x? Well, this is the same strategy, this cross multiplication. We just get an x squared, which means we have a quadratic. Now, one of our strategies for solving a quadratic is taking a square root of both sides, because a square and a square root are inverse operations of each other. So I can take the square root of both sides, right? I can't just do it to one side to get x equals the square root of 24. Now, we know that good mathematicians always reduce their radicals. So I'm going to remind myself that 24 is 4 times 6. And I'm going to use that to reduce my radical because the square root of 4 is 2. Okay, so there is my answer. Go ahead and try example 5 and come back and check when you're ready to check your answer. So number 5, the correct answer should be 6. That one, you didn't even have to reduce a radical because the radical ended up being a perfect square. All right, now tomorrow what we're going to do is we're going to look at, well, what happens if we don't just have x squared equals a number like we did on example 6? What happens if we have an x squared and an x term? That is a different type of quadratic. It's still a quadratic. And that's what we're going to learn or refresh our memory on how to solve tomorrow. If you already remember how to do these, feel free to give them a try. And this is where we'll pick up together. All right, have a great day.